So given a linear programming problem LPP, to minimize z is equal to x plus 2y, and subject to the constraints here, 2x plus y is greater than or equals to 3 and x plus 2y is greater than or equals to 6, and x and y both are positive, greater than or equals to 0, which represents in the first quadrant. Let's see the graph. Let's take first one, 2x plus y is greater than or equals to 3. When x is equal to 0, we can say from equation 2x plus y is equal to 3 to get the straight line. When x is equal to 0, y is equal to 3. And when y is equal to 0, we can say x is equal to 3 by 2. So let us mark these 2 points, 0, 3 and 3 by 2, 0. So here is a straight line which is representing 2x plus y is equal to 3, and the half plane, that is 2x plus y greater than or equals to 3, which will be against to the origin, because 0, 0 if I substitute, when x is equal to 0 and y is equal to 0, so we get 2 into 0 plus 0, which is 0, is greater than or equals to 3 is false. So we can conclude that origin is not satisfying the half plane. So the shaded region will be away from that, away from the origin. And now let us see another one. X plus 2y greater than or equals to 6. When x is equal to 0, for the equation of the line 2x plus 2y is equal to 6. When x is equal to 0, we can say y is equal to 3. And when y is equal to 0, x is equal to 6. So let's mark these 2 points. 0, 3 is the point here. And another one, 6, 0. Let's mark 6, 0 here. So here is a straight line. And now coming to the inequality, x plus 2y greater than or equals to 6, the half plane. And here also we can see when x is equal to 0 and y is equal to 0, 0 plus 2 into 0, that is 0, 0 is less than 6. So but 0 greater than or equals to 6, which is false. So we can say the shaded region to be against to the other than origin, means away from origin. Origin will not satisfy, so we have to sketch the graph. The half plane is other than that, and hence we can conclude this is a feasible region. And this is x is greater than 0, y greater than 0. And now we have the corner points, 2 corner points. Say this is A and say this is B. So A point 0, 3 and the point B 6, 0, and the value of this profit function, that is z is equal to x plus 2y. If I substitute here, you will get 0 plus 2 into 3, which is equal to 6, and here 6 plus 2 into 0, which is equal to 6. At this both the points you are getting the same value, 6. And also now we need to decide whether this linear programming problem LPP have the minimum value or not. By taking the inequality, we need to consider the inequality from the profit function, that is x plus 2y, and since we required minimum, so less than, and this value is 6. X plus 2y less than 6, which is our the second line equation, x plus 2y is equal to 6, which also represents, this is representing this line joining A and B. This is the line equation, and clearly we can see that less than 6 means which is satisfying the origin. 0 plus 2 into 0, which is 0, is less than 6, true. So the solution for this inequality is towards the origin. And even it does not touch the line because it is strictly less than 6, and hence we can say there is no common solution. There is no common solution with the feasible region. We got an empty set. Since we got no common solution, and hence we can say that the given LPP has the minimum value. And but still it since it gives two values same, 6 and 6, and also we can observe that any point on this line joining these 2 points a and b, that is x plus 2y is equal to 6 equation. Let us consider 2 comma 2 point at x is equal to 2 and y is equal to 2 also satisfies, and remaining any other point joining these two points also satisfies. Hence we can say there are we can say more than 2 points, which gives a minimum value. So graphically we can just prove it. The minimum of z occurs at more than 2 points. Okay.